Hello class, in this video we're going to be studying the INTEGRALS.7 standard, which is understanding and applying the second fundamental theorem of calculus. It's actually a very simple standard, but very confusing to understand or to forget. So if you look at your notes, and hopefully you have your notes on you, the second fundamental theorem of calculus states that if you're taking the derivative of an antiderivative that has a constant in the bottom or the lower bound and an x in the upper bound of f of t, so notice it's ddx of f of t, the answer is f of x. Or in other words, the answer is just place x everywhere you see t. And again, c is a constant. So that's exactly what the second fundamental theorem of calculus is. We'll see some sample problems, and we'll also apply it to a graph. So let's look at the first example. The question says find f prime of x, which inherently means find the derivative. So the first example, if you notice, it has a constant, it has an x, and the inside has a t. Or the two variables are different. So if I say I want to take the derivative of f prime x, or sorry, if I want to take the derivative of f of x, or in other words, f prime x, the answer is just placing x everywhere I see t. So the answer is going to be x to the third minus x. So that is essentially the second fundamental theorem of calculus. Another example is this one over here. The problem is f of x equals the antiderivative of x to pi over 3 cosine of t to the 5th power dt. This one sort of looks like that type of problem, but you may notice something different. The constant's here on the top, and then the x is here on the bottom. So the very first thing I have to do is flip the problem. So I'm going to call this negative pi over 3 to x. So now I have the constant on the bottom. So remember, if I go back to the original problem, or the original fundamental theorem calculus, the constant has to be on the bottom. So going back to the question, now I have the constant on the bottom, I flipped it and I had to add a negative. Now what I'm going to do is I'm going to apply the formula. So f prime of x is equal to, I have to have that negative, and then I'm just going to plug in the x, or the variable that was up here. The answer is cosine x to the 5th power. And there's no plus c because, as you notice, I'm taking the derivative, not the antiderivative. Another question. Adding on another layer to this. You may notice in this problem is that it's not just an x anymore, it's a 2x. So you're going to think of this kind of like chain rule. After I do the derivative, I also have to do the derivative of this term up here. So I'm going to do what I usually do. The answer to this one is I'm going to plug in this case, I'm going to plug in the 2x. Remember, that whole thing is to the 3rd power. So there you go. All I did was plug in the 2x to the 3rd power. And then I also have to multiply. Since this is a 2x, think of it as chain rule, I also have to multiply by 2. Since I'm taking the derivative of this 2x also, I did the derivative of the outside times the derivative of the inside times 2. The final answer will be 2 sine, and then I'm going to distribute that to the 3rd power. This should be 2 to the 3rd power is 8, and then x to the 3rd. That's how you take the derivative. That's how you take the derivative in case you have a non-x, or like you have an actual term here that could be derived. And then the last one. This one has 2 problems with it. Oh, sorry. This one has 2 problems with it. I have the x on the bottom, and it's an x squared. So first thing I'm going to do is I'll flip this. Like so. Okay, so all I did was flip it so it's a minus out in front, and then the constant's now on the bottom. Now I'll apply my formula, or apply the second fundamental theorem of calculus, which will be negative 3, or the cube root of 8, and I'll plug in the x squared. And if I plug in the x squared to t to the fourth, you know you're going to get x to the 8, because something squared to the fourth power will be 8. All I do is plug in the x squared. Okay. And then again, I have to plug in, or I have to multiply by the derivative of the inside. I have to multiply by the derivative of x squared. So it's going to be times 2x. Or to make it simple, the correct answer should be minus 2x, the cube root of 8x squared plus x to the 8. That's how you find the derivative of the antiderivative. Okay, and that's if you have a constant on the bottom and a variable up top. Now, a little trickier. Here's a sample problem that I'm pretty sure you'll see on the AP exam. It says g of x is equal to 1 to x of f of t dt. And this right here is a graph of f. So just in case you forget, this is a graph of f. But the questions and what they give us is g. So the first question they give us, it says, what's g of negative 4? Okay, g of negative 4. Well, remember our formula. Let me go back to the formula right here. They want to know what g of negative 4 is. Well, g of negative 4 would be the same thing as plugging in negative 4 everywhere I see x. So now g of negative 4 is the same thing as the integral from 1 to negative 4 of f of t dt. You see how this is in the wrong order? How this one is smaller than this one? So I'm going to put a negative out in front and make this negative 4 to 1 of f of t dt. So now what I'm going to do is I'm going to go back to my graph. I'm going to look at what is the antiderivative of f from negative 4 to 1. Well, the antiderivative of negative 4 to 1 is essentially the area under the curve, or the area between here and here. You may notice that this shape is a trapezoid, and it's also below the x-axis. So this one, I have a height of negative 2. I have a base of 5 and a base of 4. So the average of the bases is 4.5 times negative 2, which should be negative 9. So the area of this is negative 9. I go back to my original problem, and I'll plug a negative 9 in that piece right here. So really, this is equals negative, and then that whole thing, this antiderivative thing, turns into a negative 9. So a negative negative 9 means the answer is 9. Okay. Now, it says g of 1. If I do g of 1, you may notice that now this turns into 1. And remember, anytime the bounds are exactly the same, so g of 1 is from 1 to 1, the answer is going to be 0. There is no area under the curve if the bounds are exactly the same. G of 3, so g of 3 is going to be from, if I look at the problem again, from 1 to 3 of f of t dt. This one, my bounds are already in the correct manner. The lowest one's on the bottom and the highest one's on top. So now I'm just going to find the area between 1 and 3. So if I look at my graph again, I'll use a different color. From 1 to 3, I need to know the area under the curve. You may notice that it's a triangle. I have a base of 2 and a height of 4. Half base times height, half 2 times 4, half of 8. The answer is going to be 4. And then, just so you know, I'm not going to do it for you, but it says g of 8. So I'm going to try to find the integral from 1 to 8, or the area of the curve from 1 to 8. Now, here's where it gets trickier. What if I have these primes and double primes? What do I do? Alright, let's take a look at this. This one says g prime of 0. Okay. Remember g, if you forget, so I'll write up here, g is equal to the antiderivative of x, oops, the antiderivative of 1 to x of f of t. Okay. So now I need to plug in 0. Okay, g prime of 0. Well, you know that if I take the derivative, okay, if I take the derivative of this, g prime of x, applying the second fundamental rule of calculus, is the same thing as just f of x. Remember, the fundamental rule is if I take the derivative of the antiderivative, just plug x into here. So the derivative is f of x. So if I say I want g of 0, or g prime of 0, what I'm really saying is I want to know what f of 0 is. So I look at my graph, f of 0, remember this graph is 0, f of 0 is negative 2. Like at 0, the y value is negative 2. This one says g prime of 5. Again, g prime is the same thing as just putting it into f. So g prime of 5 is saying what is the value at 5 of this graph. So at 5, my value is 2. G double prime of 5. So if g prime of x is f of x, that tells me, I'll move down here, g double prime of x must mean f prime of x. So that tells me that g double prime is the same thing as 1 prime of f, or basically the slope. So if I want g double prime of 5, I look back at my graph. Here's 5. I want to know what the slope is at this graph. You may notice that it's a flat slope at the bottom of the circle here. So the slope is actually 0. And the last one, it asks for 1. Look back at my problem. The slope at 1, you see it's this diagonal slope right here. You could do the slope formula, so I could pick any 2 points here. So let's just say the points 2, 1, and the points 0, negative 2. Or remember, slope is rise over run. So I can do the slope formula with this, but like rise over run, meaning I go up 2 and over 1, up 2 and over 1. So that tells me my slope is 2. Or if you don't believe me, or if you don't know how I did that, you could also do the slope formula. Negative 2 minus 1 over 0 minus 2. Hold on. Negative 2, 0, negative 2, and 2, 2, 2. Sorry about that. So it should be negative 2 minus 2. I get negative 4 over negative 2, and I also get a slope of 2. In any case, I'm just trying to find the slope at this point. I know a lot of you, almost all of you, are intelligent enough to figure out how the slope of this line is. So that's it. I'm going to go over this stuff with you guys. Don't exit out on your papers. I'll just exit out here. So what your homework is over the weekend, and what the homework is rest of class, remember you're finishing the problem set from the last class. You did this notes already. You want to do the follow-up questions on Schoology. And then you're going to want to do the problem set INTEGRALS.7 on this, and you're going to submit it on the Dropbox on their weekend homework. So that's all for today. Hope you enjoyed the lesson, and I'll see y'all soon.